So today we are discussing about the pre-stressed concrete. So first, let's discuss what is this pre-stressed concrete. So first, pre-stressed concrete is that concrete in which internal stress is intentionally introduced. So we have a concrete member. Let us consider a concrete beam, and here we have a steel reinforcement, suppose the tensile reinforcement, and if you apply here the pull by the means of the hydraulic jack, you have a hydraulic jack here. This side is mainly anchored, this side is anchored, and here you pull hydraulic jack, and after some time, if you release this loading in the steel, then the steel reinforcement tries to go into the compression like this, and this compression actually is restrained either by providing the anchorage here. The anchorage actually prevents the movement of the steel back to the original position, so this steel tries to go back but can't, so the stress has to be transmitted somewhere, and this stress is eventually transmitted to this concrete, and this concrete undergoes the compression. This steel transfers its stress back into the concrete, and this is called the pre-stress. So this is the concept of the pre-stress. So in the pre-stress concrete, you actually apply the pre-compression, that is compressive force is already applied to the this concrete member before any kind of the service load is applied from the top. So this is a service load, and you apply this service load only after the concrete has already gone through the pre-compression. So here in this case, first you apply pre-compression, or it means that concrete is subjected to the compressive stress first, so that it curls into the in this way. Although it might not be visible, but tendency is that the lower side goes into the compression and this upper portion goes into the tension, whereas in the normal concrete opposite happens. When the load is applied, the lower portion goes into the tension and upper portion goes into the compression. So pre-stress actually causes this tension not to happen, so this tension is counter reacted by this pre-compressed concrete. So this portion goes into the compression, so this tension is balanced by the compression. So this is the main concept of the pre-stress concrete. And after pre-stressing, what happens? So why we use, so the question is why we use pre-stressing. Why pre-stressing? So initially we know that concrete lacks the high tensile strength, so it lacks the high tensile strength, concrete lacks. So due to this reason, when the concrete is subjected to the loading, so when it is subjected to the loading due to the flexural loads as concrete curves down, and due to this reason cracks are developed in the concrete. So these cracks actually result in the corrosion of the steels, and this corrosion results in the loss of durability in the concrete eventually. So the main purpose of this pre-stressing is to increase the strength. First of all, you need to increase the strength, and secondly, what you do is it also decreases the deflection. So when deflection is reduced or deflection, and also it increases the uh, bending, shear and torsional capabilities of that concrete element, shear and torsional capabilities. So due to this reason we provide the uh, pre pre-stressing, and this pre-stressing is also carried out in two ways. One is pre-tensioning and other is post-tensioning. So in the pre-tensioning, let's change the color. So in the pre-tensioning, what we do is there is a pre-stressing bed. This one is the bed, and you fix the two abutments which are used to hold the steels or in order to pull them or apply the tensions. So this is the steel. So this is the steel, and then you apply the tension force by the means of the hydraulic jack. This is the hydraulic jack, and other one end is anchored, and other end you apply the hydraulic jack. So this is the hydraulic jack, and the force is applied. When the tension force is applied, so this steel is then subjected to the tension. This is the abutment. So this steel is fixed in the between the in the twins abutment, and then hydraulic jack applies the tension force, and after that you then what you do is then you then cast the there is the abutment, you then cast the concrete here. Here the steel in the tension. So here steel in the tension. Here hydraulic jack is still applying the tension. So here still the tension force is there. Here till now there is no stress transfer to the our concrete. This one is concrete, and till now until you cut the tendons. So this is the steel tendons. So till you cut down the tendons, the tension force is still applied, and there is no stress transfer to the concrete. And after this concrete hardens, so first you need that this concrete hardens and gains the required strength, hardens and gain the required strength. After the concrete hardens and gains the required strength, then you cut down this tendons or cut off the tendons from the tension force. So when you do this, what happens is that this concrete has to now receive this compressive force from this steel tendons. So how this happens is that it tries to occupy the original position. So when you remove this force, tension force, it tries to come back into the original position. It tries to come back into the original position. However, there is a restraint, so this concrete is already hardened, so it does not allow the steel to go back into the original position. So instead, this compressive nature of this steel to go back is then now transferred to this concrete by the means of the bonding. So there is a bonding between the steel and the concrete, and due to this bonding, this tensile force is then transmitted to this, or this compressive or tendency of the steel to return back to original position is then transmitted to this concrete. So your steel is still maintained in the tension because it can't come back into the original position, so it is still strained, or it is not able to move, so it is still in tension. However, it wants to come back into the original position, so this tendency of steel to return back to original position is then transmitted to this concrete, and then the concrete undergoes this phenomena. So it is subjected to this compression in the bottom side and tension in the top side. So when this concrete is subjected to the compression, it counter reacts the original tendency of the we concrete which used to have tension in the bottom side and compression on the top. So for the normal concrete in which there is no any pre-stress, so normal other case for normal building scenario, this is the scenario. But for the pre-stressed concrete, the scenario is this one. So this compressive force counterbalances the tensile force during the service load scenario. So this is the main concept in the pre-tensioning. In the case of the post-tension, now we talk about the post-tensioning. In the post-tensioning, in the case of the post-tensioning, what you do is you cast the concrete by leaving a hollow duct here. This one is a hole. If you draw a cross section, there is a hole. Here also you have pre-stressing bed where you cast concrete. So this is a bed. This one is the side view, and this one is the front view. So you actually cast the concrete by leaving a duct here. So this duct is used to put here reinforcement or tendons after the concrete hardens. So in this duct you actually so in this duct you actually put a concrete, you put hydraulic jack in this one, and this side you anchor this side, and this side there is a hydraulic jack is here. So this side you put jack, this one is jack, and after this you apply the tensile force in this one also. This side also you apply the tensile force, and after applying the tensile force of required strength, you then anchor the both side. After applying the required tensile force, you anchor on the both sides. You anchor the both sides, so this both side is anchored properly so that the steel cannot move. So this steel cannot move if you anchor this. So this steel is still in tension, and as it can't move, so it tries to, after that pulling force is removed, then this tensile force actually tries to bring this into the original position. Now after removing the tensile force by the hydraulic jack, it tries to come back into the original position. However, you have already anchored here, so it can't move back into the original position. So this stress has to be actually transmitted to the concrete, this concrete, and this concrete again undergoes the compression. So it again undergoes the compression like this part is again compressed because it tries to go, because the steel tries to move back into the original position. However, it can't move down because of the anchors provided here. This anchor prevents the concrete from moving back to original position. So eventually this stress from steel is then transmitted to the concrete by the means of the anchors. So this is the concept. So in the post tensioning, anchors transmit the force to the concrete, whereas in the case of the pre-tensioning, the hardened steel actually prevents the movement of the steel to original position, and due to this reason, the bonding between this concrete and the steel actually transmits the pre-stress force and compresses the concrete. So this is the logic, guys. I hope you enjoyed this, and the concept I tried giving. So if you love this or enjoyed my concepts, you could subscribe, and I will try to bring out more